Okay, Dragons, we've just reviewed the three forms of quadratics. The equations could be written in standard form, which is y equals ax squared plus bx plus c. We get a, b, and c from doing a calculator regression. Vertex form is where h and k represent the vertex of the quadratic. And a, once again, is derived from the regression. And factored form, where a is from the calculator regression, and the two factors, the two binomials, are comprised of x minus one of the roots and x minus the second root if it exists. So keeping these in mind, we're going to play Do You Remember When? All right, so do you remember when we had a problem that looked like this? Well, I hope you do. We had two binomials, and we were multiplying them, so we used the multiplication box. Now, the only difference is we now have the two factors within the context of an equation. Okay? And so we need to ask ourselves, does this problem here look like standard form? Well, no, because there are no parentheses. Well, let's come over here and check this out. Does it look like vertex form? No, I don't have a binomial raised to the second power. But if you notice right here, hey, this is in factored form. So there should be a greater degree of comfort in looking at an equation that looks like this, because you know that you've seen it before. It is the product of two factors. Now, I know what you may be saying, Mr. Mahalik, but I don't see a number out in front. I don't see the value of a. Well, there's something there. What do you think it is? It's actually a 1. So in this particular case, a is going to be equal to 1. And if you're really curious, this right here is actually the greatest common factor of the equation in standard form, which is what we're going to convert to. So this is vertex form, and we're going to convert it to standard. Now the good news is you know how to do it. You know how to do it because there's that multiplication box there. So we're just going to do our x plus 2 for this factor. We're going to do our x minus 3. And we're actually just going to multiply them. Now let's go down memory lane. X times x is x squared. X times negative 3 is negative 3x. 2 times x is 2x, and 2 times negative 3 is negative 6. We can combine these to create an answer of x squared minus 1x, because that's what these two guys combine to be, and then minus 6. So now, as we take a look at this, we now have standard form, where a is an understood 1, the coefficient of the quadratic term. B is going to be negative 1, coefficient of the linear term. And C is going to be negative 6, which, if you remember, that's going to wind up being my y-intercept. Let's play Do You Remember When again. Do you remember when you were asked to factor trinomials? I hope so. So we used the factoring by grouping method. We multiplied a times c, 2 times 2, and said we want a number that multiplies to 4, positive 4. And then we looked at this middle term right here and said, okay, but we also wanted to add to 5, positive 5. And we go through and we make Oop, dry board just fell. At least my camera didn't fall. Ah. All right, so 1 times 4, 2 times 2, -1 times -4, all of those multiply to 4, but only one of these adds to 5, and that would be this one right here, so we don't need these two guys. And so we use that to break it up into a 4-term polynomial. So I wrote 5x as 1x plus 4x, and everything else stayed the same. And then we factored by grouping, taking out a greatest common factor. Greatest common factor of this will be x, leaving a 2x plus 1. And now I need a 2x plus 1 on the other one. And so 2x times 2 is 4x, so the GCF of the second group is a positive 2. And then we took these two greatest common factors in the grouping process and made them a binomial of their own. So they created x plus 2, and we just wrote down the other binomial right there. So, look what we've done using prior knowledge. We have taken a problem that was in standard form, where A was 2, B was 5, and C was 2. And we've now written it in vertex form? No. We've actually written it in factored form. Okay? So remember, just because the formula has a minus sign, if you subtract a negative, you actually get a positive. So this is really x minus a negative 2, and so on. Okay? So you can convert from one form to another simply by using prior knowledge. Okay? So now let's really go back. Do you remember when you studied PEMDAS in middle school? Because now whenever we take a problem, which is in, what form is this? Is it standard form? No. Oh, there we go. I think this is vertex form. Okay? Because A would be 2. I got my parentheses right here. All right. So if we want to convert this into standard form, we're going to follow the wonderful rules that our middle school teacher taught us, which would be PEMDAS. So we need our grouping symbols, and then we work our exponents, and then we multiply and divide from left to right, and then add and subtract from left to right. So the first thing I see in this problem is I have a binomial being squared. Well, how do we multiply x plus 2 by itself? That's right, we're going to call upon prior knowledge, and we're going to do an x plus 2 times an x plus 2. This is going to be a trinomial square, so if you know the shortcut you could use it, but if not, the box always works. X times x is x squared, 2 times x is 2x, 2 times x is another 2x, and 2 times 2 is going to be 4. So if I combine my like terms, and I do my exponents, if I multiply these out, I get the trinomial x squared plus 4x plus 4. I got that directly from my multiplication box. We bring down the 2 that's in front of the parentheses, keep that trinomial in parentheses, because it's still being grouped, and I have minus 7. Okay, so what does my order of operations say to do next? I've done the exponents, and now I need to multiply. I got a multiplication of 2 times this trinomial, so I'm actually going to have to distribute once, twice, 3 times. I'm going to distribute a 2 to the trinomial. 2 times x squared is 2x squared. 2 times 4x is 8x. And 2 times 4 is 8. So this, after we distribute, the parentheses goes away. Now all I got to do is subtract 7. So now I'm down here on adding and subtracting. The only like terms I have now are these two guys. So now I get 2x squared plus 8x plus 1. And I remember that this is an equation, so I need my y equals. And look what I've just done. I've gone from vertex form to standard form, where a is 2, b is 8, and c is 1. So I'll do one more with you, and then you're going to be able to practice some of these on your own, converting from one form to another. Okay? Again, I can't actually subtract x and 1 because these are not like terms. So if you're wondering why I'm skipping the parentheses, is that these are not like terms. There's no work to do inside of the grouping symbol. So that's why I go to the exponent right here, and the exponent is just on the binomial. So I'm not going to square a -4 because it's not inside of this grouping symbol. This exponent just goes with this grouping symbol. So I need to multiply x minus 1 by itself. Remember, a negative times a negative is a positive. And I write that trinomial. You got x squared. These aren't zero pairs. This is going to be a negative 2x. And a negative times a negative is a positive. So now I have y equals -4 times the result, which I've written in trinomial form, and then I have a plus 3. Next, my order of operations is to multiply. That's the distribution. So I'm going to multiply everything of this trinomial times a -4. Negative times a negative is a positive 8x, and a -4 times a positive 1 is a -4. And then I can tack on my plus 3. And now the only things that are like terms are these two guys right here. And a -4 plus 3 is going to be a -1. So what have we done? Once again, we've taken something that is in vertex form. We followed our PEMDAS, and now we have something that's in standard form. Now, how are you going to check these? Well, hopefully you remember that what we can do is we can go to our calculator. So in the first starting equation, we can just type in a -4 parentheses x minus 1. Make sure you square it. And then plus 3. And now we can write in our answer in standard form. -4x squared plus 8x minus 1. Now we can either look at the graph or we can go look at the table. If you notice that the outputs for both equations, the beginning equation and our transformed equation to standard form, notice the outputs are exactly the same every single time. If we hit graph, we're going to have a single parabola show up. The other one overlaps it exactly. They wind up being the same parabola.